Hello again to everyone. So I'm back with a new topic, optimization techniques, and one topic to rule them all. So this optimization technique is used everywhere. I think everyone is familiar with that. Um, the final task in your job is optimizing what you did, whether you write software or whether you produce accounting results, prediction, everything. Your final task is always optimization. So I will cover brief about what is optimization technique in more formal terms, in terms of mathematical sense, what is optimization technique. And I will talk about one method to solve very simple optimization um, problem. We'll formulate a problem and solve that optimization problem. And finally, if there is enough time, I will introduce how this optimization technique is used in machine learning, and we will go into the details. So I'm expecting lots of interaction, lots of questions. So this might be a confusing topic. So uh, so these are the contents. I will talk about introduction, what is optimization, applications, what are applications of optimization, very high level, and talk about formulation, how the optimization problem is formed and how it is solved using one technique that uses derivative, fancy calculus term. And finally, I'll talk about optimization in machine learning, and we will spend most of our time in Q&A. So first, the meaning of optimization. So this optimization in English and in mathematics, technical optimization is a little bit different. So in English, it is like take action of making the best or most effective use of situation or resource. It is optimization in English, and optimum is the most favorable condition um, for growth, reproduction, or success. So these are definitions from Google. So, but in mathematics, optimization means either maximum or minimum value of some function. So it does not mean something in the middle that is just suitable for, like in the example before, plant growth. It is not like something in the middle. It is either maximum or minimum. And in mathematics, this optimization technique field deals with finding the best alternative out of all given set of alternatives. And and if you talk about alternatives, if there are a finite number of alternatives, you can iterate through every one of them, check which works, and be done. You will always have optimum results. But in real life, in more complicated situation, in more practical situation, you cannot list all the alternatives, and you have to select one among whatever you can. So more formal definition. So the optimization is a basic form of problem in optimization is to identify alternative means of achieving a given objective. We always have one objective, and then select alternative that accomplishes the objective in most efficient manner, subject to constraint on the means. So that objective can be achieved by using different methods, but in practical optimization problem, we always have some kind of constraint. We cannot have like imaginary values that explode everywhere. So we always have constraint, and we always have objective. So there is another term more friendly for someone familiar with programming. So it is just like rewording, so I'll not go through that. So in optimization problem, the goal when we talk about optimization and optimization problem is there should always be a quantitative measurement that specify what alternatives are. There should always be a number or equation that we can quantify, or a function. If you remember the last session, everything in this world is represented by function. So you should have a function that specify the alternative. and there should be a mean to say one alternative is better than the other. So it cannot be some qualitative, or it cannot be like intuitive. You cannot say, according to my intuition, this is better than other. There should be something measurable, and that should be used as the selection metric. Um, and when you choose one alternative, you have to be able to quantify its value, cost, or benefit, or some other measurable parameter. This is just repeating the second bullet. And finally, you need some kind of constraint or some bounds to define what it means to be a feasible alternative. So these are the basics for optimization problem. So you have to have some mathematical equation for defining what is alternative, how to measure one alternative, difference between two alternatives. So these are the basics. So if you talk about the applications, there are like a lots of application. It is used everywhere. So every field has separate specialization in optimization. So you can imagine how large this field is and how important this field is. Like some of the applications that we might be familiar, everyone might be familiar, is operation research, how to find the optimum path for, let's say, a product delivery, and how to find variables that maximizes the profits, all these operation research, and how to determine the perfect timetables and schedules that fits everyone, and how to determine the performance of complex systems like power system, internet softwares. Those are all optimization techniques. And electronic designs heavily uses these optimization techniques. This is from the experience. And learning systems, meaning machine learning systems, the whole basis for learning system is optimization. And it is heavily used in economics, lots of theory in economics, and many scientists working in economics have contributed to theories in optimization techniques, and also in control theory, like controlling the speed, controlling the motors, and all those kind of things, and many more. Like if you remember the introduction from games, computer games, to electron colliders, everywhere there is optimization technique. So today, so what I try to do is make a model for Spiralogics profit, of course, a toy model, and find a condition for maximum profit in Spiralogics. So this is what I'm going to do today. So to do that, what I need to do is first collect the data from Spiralogics, and I will define a problem, what I'm trying to solve and what I'm trying to optimize. And I will model that problem using mathematics or some program. And then last step, to validate and to actually apply so that our management can have use profits. So the first is data collection. Yeah. So this is data collection is like first step in everything. So no wonder this is first step in formulating optimization problem. So like data collection in all fields, this can be time consuming, but this is the most fundamental thing for model building process, and it is extremely important. And availability and accuracy of this data will determine the accuracy of our whole model. So in our Spiralogics profit optimization task, so we will collect number of teams, we'll collect all the accounting reports from accountants and HRs, all the costs and profits, so we'll have all those data. And the most difficult part is problem definition and formulations. How do you formulate a problem? So let's talk about some formal definitions or formal jargons in optimization techniques. So what you need to do at first is you need to find what are the decision variables. Decision variables are those variables that define the outcome. So this is the decision variables. And next is formulation of model objectives. So what is your objective? So you have to formulate a model. So that will depend on decision variables. And finally, is you have to form the model constraints. Constraints are what limitations do you have, like constraints on um, number of people, number of teams, and those kind of things. So you should always consider while forming this, you should always consider what are the important elements of your problem. So important element in one problem will not be important in another problem. So there is no one golden rule for everyone to follow. So you just have to keep in mind what are the important elements. You have the data from before, just take that and use that to determine the important elements. And you have to determine number of independent variables and number of equations required to describe the system, and what are number of unknown parameters. So this, you have to form some models, and you have to determine some equations that roughly um, forms the model. So one very easy, the first task one can do is plot the data that you have and fit some curve to that data. So if you fit that curve to that data, you will get the model and variables and everything. And one important thing that that is overlooked in many places is like you have to fix you have to be very careful about independent variables. Independent variables are variables that do not depend on other variables, like for example number of teams and number of employees. Those can be dependent variables. We can just use one to represent the whole problem. So given the condition, there are a fixed number of people in a team. So just be careful about independent variables. If you have more than one independent variables, the problem becomes complicated and you might not have a solution. And the third bullet is again looking at the complexity. Look at the independent variables, try to minimize the complexity. Simpler the better. And while solving, you have to keep in mind on what degree of accuracy do you want. So if you want like to 3 decimal places, profit estimation up to 3 decimal places, then it has to be very accurate. Your model has to be very accurate. But if you can tolerate few thousands, then you will have more room to wiggle around. And also your model will be simpler. So let's formulate something for, let's define the problem for our Spiralogics profit optimization thing. So we'll have some profit pie. So that is, we'll maximize this pie. That is our objective. So our decision variables is number of teams. And there are other parameters like expenses, salary budget for team, and revenue earned from each team. So these are all other parameters. And from the data, I made a few assumptions just to make a toy problem so that we don't actually make something that can optimize the profit. um, so to simplify, revenue is dependent on number of teams. So everything is dependent on number of teams. We only have one independent variable. So each team always has a fixed number of employees. So number of employees is also dependent on number of teams. And expense is squared of salary. Um, so just assuming one relationship, how the expense and salary is related, just assuming the salary so that I can demonstrate some quadratic equations. So there is fixed expense for rent, parking, operations, etc., and constant is 100 teams. So we will form that. So if you remember from the last, so everything can be represented as a function. So we will represent our profit model was profit model of Spiralogics as function. So just to be clear, so this is a toy example, and in real world, when you solve real world problem, so it is a lot complicated to define a model. So there can be multiple decision variables in a problem, so that will increase the complexity. And it is not always clear about the nature of relationship between decision variables and the outcome or the objective. So like for example, in government spending, in education, it is very difficult to determine the relationship between the expenditure and the benefits of income, employment, productivity it provides, and how it is affecting the education as a whole. And so for us, for in the TOEIC problem, we just had one constraint. The number of teams is less than 100, but in actual, there can be many complex constraints. Like even the model itself should most of the time incorporates the constraint in the model itself, so it becomes rather complex. So, but still, most of the problems can be model and are solvable. And finally, so there is totally different topics about uncertainty and risk in models. So there are uncertainty and risk, and forming an optimization problem is always complicated in the presence of uncertainty and risk. So the next step um, is the model development. So what we do after we observe what are the variables and we observe the data, so we make the model. Model meaning we make a function, mathematical description. So if there are parameters, we estimate the parameters using curve fitting or any techniques. So we develop what the input should be and what the outcome should be based on. We develop the inputs, and if it is too complicated, we develop the software. So for Spiralogics profit optimization, so what I did is profit will be equal to some revenue that each team generates R into Q, and some fixed expense E, and this relationship with salary S, and so that will be depending on square of the number of teams. So this is, and after parameter estimation, so assuming we got the data from accounting, HR, everyone, and estimated the parameters. So this is some model we get for Spiralogics profit to estimate the profit. So the objective for us will be to optimize the number of teams so that Spiralogics gets maximum amount of profit. So if when number of teams increases, the revenue increases, but so does expenses because more expenditure and salary. So this is a model, and so practically this model development phase is like iterative process, and it will require returning to the variable definition, parameter estimation, and everything again and again to create the accurate model. So the next topic is model validation. So this is something that we do to validate the model. So this just plugs in the known inputs and gets the known output and measures the error from the model. So you get the root mean squared. Usually root mean squared error is used to measure the performance of a model. So you can also do other fancy stuffs like sensitivity analysis, or sensitivity analysis meaning how the input affects the output in actual world and in your model. If it is your output is too sensitive to some inputs, then it's not good. So you can do all these kind of validation. And one important thing is when you create a model, you use a set of data, but when you validate, you should always use different set of data. This is fundamental 101 of creating models. Also in machine learning, this same concept applies. So we formed one equation. So we want to optimize for number of teams. So how do you optimize? So this optimization methods, there are like lots and lots of methods, but I will cover briefly about optimization using differentiation or optimization using calculus. So this is mostly used in machine learning and AI these days. So covering this. So the first thing we need to know to solve optimization is something called derivative. Many of you must be familiar with derivative. So what does derivative actually do? So derivative calculates a slope of a curve. Like for example, if you have a curve and if you calculate a derivative at a point, so derivative will always be at some point. If you calculate derivative at a point, then you will get the slope of that curve at that particular point. So more fancy term is you'll get the slope of that tangent through that point. So if you look at this curve, so you will always have a slope. Imagine slope as just this incline, even if you don't remember the high school geometry. So slope is some incline. And if when this slope is 0, you will reach a maximum value. So how? So just imagine you are at the top here and try to make a tangent at the top. So you will not find an incline, but you will find something that is parallel. So it will have a slope of 0. So that is the maximum point. So that is how you find the maximum. So one formula, and the screen is just shows what is derivative, mathematical definition of derivative. So this condition that says something is maximum or minimum when the slope is 0 is also called first order condition. So some formulas for reference if anybody is interested. So I'll skip that. So some more about derivative. So if something is parallel to x-axis, so you don't have a slope, you don't have a slant, so derivative is 0. Like for something constant function, y is equal to 4, y is always 4, there is no slant, so you have a derivative of 0, slope of 0. So let's see for b, something that is linear, so that passes through this 0. So this equation is 2x. So if anybody remembers coordinate, so if it passes through 4, it will be 2x plus 4, mx plus c. So 2x, the slope is 2. Here 2. So to using this formula, or this fancy formula, you can get derivative is 2. And for something more non-linear, something like this parabola, equation is y is equal to x square. So this derivative will be 2x. So this is how you calculate the derivative. The derivative of something flat parallel to axis is 0. Derivative of linear thing will be some number constant, and derivative of non-linear will have a variable in the derivative itself, like 2x for this parabola. So that is derivative. So our Spiralogics profit optimization problem, we have this pi is equal to minus 40, 140 plus 140q minus 10q squared, just putting it into constant and first order, second order form. So middle term is revenue and 2 are expenses. So if you calculate the derivative of this, so derivative of 40 will be 0. Derivative of 140 is just like a slant that we saw. So 140q will be 140, and derivative of 10q square will be 20q. So 2 will come to the front, 2q, 10 into 2q, so it will be 20q. So this is the derivative. And to find the optimum number of team, what we do is just equate this derivative to 0. So if you solve this, then you will get what is the optimum q to maximize the profit for Spiralogics, the number of teams to maximize the profit. So this is derivative. I think everybody can solve this, right? Can somebody speak up the solution for Q?
7.
Yeah, that's right. Okay, if there are 7 teams, we'll have maximum profit. That's okay, that's correct. Okay, so let's draw the graph and see our theory of optimization and slopes. So this nice equation has this kind of graph, minus 40 plus 140q minus 10q square. So we have this graph that goes up and that goes down like inverted parabola. So the maximum will be at a point where the derivative is 0. So derivative is 0, meaning slope is 0. So if you go from the left and up, so you will always have some incline. So slope will not be 0, but at the top, you will have the slope of 0. And if you see the x-axis for that to q, then you will find it is 7. So that is what we got from the that is what we got by solving that equation's derivative equals to 0. So plotting the derivative, you will get this kind of line, and again, just another way of showing this one. So that is how we got the maximum profit with 7 teams. But there is some problem with just using that derivative and equating that to 0. So in our problem, we want to maximize the profit, but also the derivative will be 0 when the profit is minimum. So it works both ways. So you can find a minimum or a maximum by equating the derivative to 0. So that derivative condition is not sufficient. So if you see the plot here, plot at the bottom, you will see derivative equal to 0 at 2 point, 1 at maximum, and 1 at minimum. So derivative equals to 0. It is a necessary condition, but it is not sufficient to solve any optimization problem. So what do you do? So what we do is we calculate the derivative of derivative. So slope of the derivative again, and if slope is if that second order derivative slope of derivative itself is less than 0, then we have the maximum point, and if it is greater than 0, we have the minimum point. So I have a big typo here. The second is minimum, the first is maximum. Okay, so if you look at this curve and make the slope at each point, calculate the slope. So when slope is less than 0, you get the maximum, and when slope is greater than 0, you get the minimum. And if slope of the derivative itself is 0, it is not deterministic. You cannot determine whether it is maximum or minimum. So that is the optimization technique using derivative. So you have to calculate the derivative, and to determine whether it is maximum or minimum, so you have to calculate the derivative of derivative. So in this case, what will be the derivative of derivative? So it will be just minus 20 q minus 20, not even q, just minus 20, and minus 20 is less than 0. So that point is maximum. So that is how we solve. So this is the very basics of optimization technique. So what I showed you is just one variable and very simple, very nicely behaving curve. So it's so it is easy to solve, but in practical sense, you will have like more complicated curve and many variables, but those can be solved. So if you get this fundamentals and look at how to solve multivariate optimization techniques, then you can solve any optimization technique. So we are already 40 minutes in. Um, Optimization in machine learning. So next is optimization in machine learning. So last time I covered perceptron and equation for a neural network. So what I want to cover how learning is done, but to cover that, there are few fundamentals that we need. So don't get scared by all these equations. So just know that there is a fundamental called loss function. So this loss function is same as the objective in the optimization that we just saw. So pi in our SPO problem that we solved. So this loss function is calculated in machine learning by comparing what we observe y hat and um, what is actually there y. So y is the prediction of some machine learning algorithms, and y hat is um, sorry, y is the true label, and y hat is what your algorithm, what your model produced. So, and if you compare those and formulate some algebraic equation, you formulate this loss, and that loss is used as the objective that you optimize in machine learning. So some examples of these loss functions are like quadratic loss functions, so that you don't negative and positive have like similar effect, negative error and same positive error, they have similar effect. So you usually this quadratic loss is utilized. So this gives very nice quadratic curve, like we saw the parabola, something like that. So this is used most often. And there is also another loss called absolute loss. We had minus y, so always get the positive one. So you will see like tens and more, maybe hundreds of loss functions that different people use for different problems. So that is the loss or the objective. So that loss, what we just saw is a loss for just one single instance, one prediction. So if you have thousand thousand images, so that loss will be the loss for one image prediction. Or if you have 1,000 data points, that loss will be for one just single. So if you take that loss and average it out over all the uh, points that you have, if you have n points, if you just average that, then you will get something called empirical risk. So another fancy term used in machine learning theory a lot. So why empirical risk? Empirical means something that you observe with experiments. So there is another absolute risk. So that is with 100% you know the risk. So you can never observe like each and every data points. If you could observe every data points, then you would have perfect model. So, but you cannot observe everything. So you just take sample of some data points and calculate the loss or calculate this risk. So it is called empirical risk. So just a fancy term. So again, don't get confused with this. Uh, the fundamentals. So the first is loss function. You compare what you get from your model with what the model should actually produce. So that is the loss function, and average that loss over all the points that you have. That is the risk, empirical risk. So um, you can, again, this is specifying loss in terms of other Another function G. So this is G is actually your model. So you feed some data set Xi, Yi, and get the loss for that model. So this is all fancy way, but the thing that you need to understand is loss is average of all the cost. So what do you do in neural network and machine learning in the end is now you just minimize that loss. So when the loss is minimum, so the error, the prediction error will be minimum. So when this loss grows more and more, your prediction error will be less and less. Sorry, your model's accuracy, the predictions accuracy will be less and less. So the objective in the end is to minimize this loss function, this empirical risk, what you get. So if the models were simple and you could get a quadratic equation like what we got for Spiralogics profit optimization, then you could just always solve to get the optimum value. But in reality, like I said earlier, you don't get that smooth curve, and and the model does not behave rather well when you just take the derivative randomly. So there are lots of variables. This theta, if you remember, I forgot to explain. So this theta is the weights of the neural network or the parameters of the machine learning model. Last session we used W, but now we are using theta. So there can be like hundreds of millions of weights. So I think in GPT-4, there are billions or trillions, no, 22 billion or something weights. So to solve this using deterministic derivative method is rather difficult. So what we do to solve this optimization problem is we use something called gradient descent. So what this gradient descent does is you take a loss function for a set of parameter theta, like theta, let's say 22 billion weights, and loss using that 22 billion weights. So you can plot this one-dimensional plot. So, and using one set of weight, you calculate that loss uh, and get a point. So, and you want to minimize the loss and reach to the minimum level. So this bottom of this parabola. So what you do is the same technique of gradient. So if you take the gradient at this point, you will get the slope, and this slope will determine which direction to move. So for example, if this big black point was on the left side, you would get like opposite gradient. So, and you adjust these theta, so in the opposite direction of the gradients, and again calculate the loss, and again calculate the gradient, and again adjust according to the gradient, and you try to reach the minimum. So that is how learning happens in gradient descent. So this is again very high level. So this is not taking any examples or any models. I'm not showing any solution to any problem, just the basic concepts. Okay, yeah, I reached the end.